Hello, in this video, I will show you how to determine the optimal number of clusters in a cluster analysis using R. This is similar to determining the number of latent factors in the factor analysis. I want to load in these R packages, cluster, factor extra, NbClust, and for graphing ggplot2. Okay, so I already installed these packages in my RStudio, so I just load them in. Set a random seed, sample size is 200, and we'll generate a data set with 2 clusters. Okay. And the variables, we call them feature 1 and feature 2. And this is the data structure for clustering. So we wonder how many clusters are there. We can plot out the data. It looks like that, like 2 clusters, right? There's a point in the middle which may become difficult to classify into cluster 1 or cluster 2. Okay, but we'll just leave it there for now. Okay, so to determine the optimal number of clusters, there are multiple approaches. The first one is called the elbow method. We use the fvs underscore NbClust function. And the syntax is data k-means. So we tell this function we're using k-means for clustering. And method WSS, please refer to the our documentation to find out the technical details of a WSS. So my R videos here are showing you the implementation of different methods. Okay, so you can read the books, papers, and R documentations for technical details behind these methods. Okay. So let me draw it out. So on the right-hand side, you can see the graph. This way, we call it an elbow graph. It drops down from cluster 1 to 1 cluster to 2 clusters, and then it becomes like an elbow shape. So the optimal number of clusters should be 2 here. Okay. The second one is the Silhoutte method. If you remember the Silhoutte statistic, we talked about it. The closer it's close to 1, the better of the cluster. So we can use the same function but different method equal to Silhoutte, and then it look like that. So this one, the higher the data points, the better the clustering. So also 2 clusters is the optimal one. Okay, and there's another approach called the gap statistic. I think this is a similar statistic called the gap statistic compared to the Silhoutte value. So let's set a random seed. We use the function class gap to compute it with different options. And then we plot it out. It looks like that. So similar to the Silhoutte method, but this graph, in addition to the point estimates, it also add confidence intervals there. Okay, but it also shows 2 clusters is the optimal number of clusters. Okay, and then if you really want to experiment many different methods, the NbClust package is really written for estimating number of clusters. It has so many methods implemented. So we can set a random seed. So this syntax of the NbClust data, and then this equal to null, distance is Euclidean, minimum number of clusters 2, maximum number of clusters 10. So we're experimenting between 2 and 10 clusters. Method equal to k-means, index equal to all. So we want all the method. You can see up there the output. It tells us there's 13 proposed 2 clusters, 2 propose 3, 5 propose 5, etc., etc. So the conclusion based on the majority rule, the best number of clusters 2. Okay. On the right side, also there's some graphs about the D index, that comes with this function here. It does have FV's NbClust function, graphing function, but when I try to use it, it keeps giving me some errors which I could not fix in a short time. So I basically wrote another version. I call it the my FV's NbClust function. I already read it into my R session, so I can just use it. The detailed syntax is at the end of this R command file. Okay, so let me just make the graph. It's a bar graph showing the frequencies of how many methods recommended the certain number of clusters. Okay, so you can see 2 clusters has the highest bar, so that's the most recommended. Okay. So we choose 2, and if you want to be more fancy with numerical values, then we can get all these frequencies, and we can pick where it's recommending. Okay, the highest frequency. So it's 2 clusters. Okay. So once you have determined the optimal number of clusters, you can rerun the k-means clustering using the optimal k. Okay, so here optimal k is 2. We use the k-means again, and then we can take a look at the Silhoutte width, and this is what it look like. So it's 2 clusters, and you can see the higher value, they're all like above 0.75. Okay, so they're pretty good. The closer to 1, the better. Okay, and the next are the syntax of the myFV's NbClust function. Okay, so okay, I showed you a few methods for determining the optimal number of clusters in the cluster analysis using R. In real data analysis, your data may not be this clean. The clusters may not separate it very well, so you may have some difficulty to make decisions. Okay, but if you try the NbClust function, you get about 19 methods. You can try to use the majority rule to help you to determine the optimal number of clusters. Okay. All right. Thanks for watching. Yeah.